माय डियर स्टूडेंट्स, हम लोग आज कुछ हेनरीज लॉ पर न्यूमेरिकल्स देखते हैं. लेट अस सी. H2S. H2S, a toxic gas with rotten egg smell, is used for the qualitative analysis. If the solubility of H2S in water, if the solubility, if the solubility of H2S in water, H2S in water at STP is 0.195 m. M means molar solution. Calculate KH या KH डिटरमाइन करना है इस क्वेश्चन में. NCERT का क्वेश्चन है. दिस इज द NCERT क्वेश्चन है. लेट अस सी हाउ दिस इज सॉल्व. इस क्वेश्चन के में 3 टर्म आपको डिटरमाइन करना है. आपको केच निकालने के लिए सबसे पहले मोल्स निकालना होगा, तो मोल्स ऑफ वाटर डिटरमाइन करेंगे. उसके बाद मोल फ्रैक्शन ऑफ हाइड्रोजन सल्फाइड निकालेंगे और तीसरा टर्म होगा केच निकालेंगे. केच निकालने के लिए हम लोग को ये 2 टर्म चाहिए, नंबर ऑफ मोल्स ऑफ वाटर और नंबर ऑफ मोल फ्रैक्शन ऑफ H2S. सो अगर 3 टर्म इस क्वेश्चन का डिटरमाइन करना है, तो पहला टर्म हम लोग देखते हैं. अब इसको निकालते हैं n ऑफ वाटर. n ऑफ वाटर निकालने का तरीका होता है वेट बाय मास. तो वेट बाय मास. सो इन मोलालिटी वी टेक 1000 gram, that is per kg of the solvent. 1000 by 18 is equal to 55.55. This will be the number of moles. So total moles will be 0.195 in the question and 55.55. So total moles would be the sum of 0.195 plus 55.55. So mole fraction of H2S would be, mole fraction होता है क्या है, 0.195 by total moles. 0.195 plus 55.55. So this would be 0.0035. So pressure of H2S at STP is 0.987 bar. It should be taken. So P of H2S is equal to KH into mole fraction. Therefore KH is equal to ये हो जाएगा P of H2S by mole fraction. So P of H2S is 0.987, that you know, and X be the mole fraction. So mole fraction, what we have got, 0.0035. So the calculation, it will become 282 bar. So this is the way to solve this question. H2S, a toxic gas with a rotten egg smell, is used for the qualitative analysis. If the solubility of H2S in water at STP is 0.195 molar, that is molality, calculate KH. So how KH is determined? KH डिटरमाइन करने के लिए हम लोग को 2 चीज़ डिटरमाइन करना होगा, नंबर ऑफ मोल्स एंड मोल फ्रैक्शन. सो वी कैन अप्लाई दिस फार्मूला एंड हेनरीज लॉ कैन बी मेड applicable. So the next Henry's law constant for CO2 in water is Henry's law constant, that is KH for CO2 in water is equal to, ये दिया हुआ है 1.67 into 10 to the power 8 पास्कल. This is the KH value. It is a second question. At 298 Kelvin. At 298 Kelvin. Calculate the quantity of CO2 in 500 ml of soda water. Calculate the quantity of CO2. Quantity of CO2. Quantity that is mass or moles. Quantity of CO2 in 500 ml. In 500 ml of soda water. Soda water. When packed under 2.5 atm CO2, when packed under 2.5 atmospheric pressure at 298 Kelvin. So KH is equal to here 1.67 into 10 to the power 8 Pascal, and P of CO2 is given in the question, that is 2.5 atm, 2.5 atm, and it should be turned into the Pascal on multiplying 2.5 into 101325. So now P of CO2 is equal to, we know, KH into mole fraction of CO2 according to Henry's law. So mole fraction of CO2 is equal to P of CO2 by KH. So P of CO2 is already known, 2.5 into 101325 by, and KH value is given 1.67 into 10 to the power 8 Pascal. So it becomes 1.517 into 10 to the power minus 3. Now we will calculate the mole fraction of CO2, and then we will put the number of moles. We can get the mass of CO2. So the next, let us see the other part of this question. Now we have calculated mole fraction of CO2, mole fraction of CO2 here. So now we will calculate the number of moles or mass of CO2. So mole fraction of CO2 is equal to moles of CO2 by moles of CO2 plus moles of water, and it becomes moles of CO2 by moles of water, because for very dilute solution this denominator part is neglected here. Therefore water 500 ml is equal to 500 ml water is equal to, we consider here molality 500 gram. So we can calculate number of moles of water is equal to 500 by 18. This is equal to 27.78. Now N of CO2 by N of H2 is equal to 1.517 to 10 to the power minus 3. So N of CO2 is known, and N of water. N of CO2 has to be determined, and N of water has been calculated here 27.78. So we can determine N of CO2, and then it is multiplied by molar mass, so as we get mass of CO2. So N of CO2 would be, N of CO2 would be N of water into 1.517 into 10 to the power minus 3. So N of water is 27.78 that I have got, into 1.517 into 10 to the power minus 3. It should be multiplied to get the moles, that is 42.14 into 10 to the power minus 3 And now we have to calculate the mass of CO2, and as we all know, the molar mass of CO2 is 44, so it is multiplied by 44 gram per mole, because it is a molar mass of CO2, and the moles what we have got 42 into 10 to the power minus 3. So the mass of CO2 would be 1.854 gram. So this is the solution of that question. I think you have well understood. I hope आपको ये वीडियो समझ में आया होगा, आप इस न्यूमेरिकल को ज़रूर कर पाएंगे. This question has 3 or 4 steps. Now we will see the another numerical problem. The partial pressure of ethane over a solution containing 6.56 into 10 to the power minus 2 gram of ethane is 1 bar. If the solution contains 5 into 10 to the power minus 2 gram of ethane, what shall be the partial pressure of gas? So it is quite easy to solve that. The pressure at STP, as we know, pressure at STP is 0.987 bar, and we also know M be the mass of the gas dissolved is directly proportional to P of gas, that is KH into P from the Henry's law. So therefore KH is equal to M by P. From this equation we can write KH, that is called Henry's law constant. KH is equal to M by P. So M is given 6.56 into 10 to the power minus 2 divided by 1. That is 1 atmospheric pressure, 6.56 into 10 to the power minus 2. This would be the KH value, and the unit of KH is similar as that of the pressure in second case. This is the first case. In second case, M is equal to 5 into 10 to the power minus 2 gram. This is already given. So P is equal to M by KH, and M is the 5 into 10 to the power minus 2, and KH is given Henry's law constant 6.56 into 10 to the power minus 2. So we get on division 5 into 10 to the power minus 2 divided by 6.56 into 10 to the power minus 2. So we get 0.762 bar. 0.762 bar. This is the partial pressure of the gas, and this has to be determined. The partial pressure of ethane over a solution containing 6.56 into 10 to the power minus 2 gram of ethane is 1 bar, and if the solution contains 5 into 10 to the power minus 2 gram of ethane, what shall be the partial pressure of the gas? So it is quite easy to determine. First of all, we determine KH value, and then it should be put into the formula P is equal to M by KH, and so as to get 0.762 bar, and this is the partial pressure of the gas. Now we will see one more numerical. KH for the molarity of methane in benzene at 298 Kelvin is 4.27 into 10 to the power 5 mm of Hg. This KH is given, and this is 4.27 into 10 to the power 5 mm of Hg. Or this is the KH value. Calculate the solubility of methane in benzene at 298 Kelvin under 760 mm Hg. So it is quite easy to solve that. KH is given 4.27, KH is already given 4.27 into 10 to the power 5 mm of Hg, and pressure to 98 Kelvin under 760 mm of Hg. It is already given, so 760 mm of Hg. So P is equal to, as we know, KH into X, and therefore the mole fraction of methane in benzene, would be P by KH. So here P is given 760 by KH is already given 4.27 into 10 to the power 5 mm. So on division we can get 1.78 into 10 to the power minus 3. So in this way we can solve this numerical. So here X of mole fraction means the mole fraction of methane